So, good evening, everyone. Myself, Kumari Priya, and I'm currently doing my PhD from IIT Roorkee. And this course is a part of my PMRF TA duties. So, I'll be taking live tutorial classes for the course selection for nanomaterials for energy harvesting and storage applications course, which is a 4-week course. So, I'll be taking four live tutorial classes, in which we will be basically, it is a class in which I have to discuss some of the assignment questions or some of the questions, means some extra questions. Okay. So, have you guys attended Professor Kaushik Pal's classes for the week? Anyone? Okay, then. So, along with the classes, I will be giving a gist of all the content that Professor Kaushik Pal has taught in the last week, in this week. Okay. So, will that be fine, or are you guys okay with the questions only? I believe that would be fine if I give a brief gist of whatever there is, whatever it is there in the course, rather than just solving the questions. So, let me share my screen. Is my screen visible to you guys?
Yes, ma'am.
Yes, ma'am.
Is my screen visible?
Yes, ma'am.
Yes, ma'am.
Hello.
Yes, ma'am. You are audible, and
Am I
you are.
audible to you guys?
Yes, yes, yes.
Hello. Could anyone please answer me so that I can proceed with the class?
Yes, ma'am. Audible and both
Yes,
visible.
ma'am, you. Yes, ma'am, you are audible.
Okay. Okay. Guys are not audible to me. Okay. So let me share my screen. These are the slides that I have prepared. Okay. So today is the first tutorial class for the course Selection of Nanomaterial for Energy Harvesting and Storage Applications. So as you guys may be knowing that it is well known that we are currently in a energy crisis. The world is facing an energy crisis. So basically what energy crisis is that we have used so much of the non-renewable energy resources. We are so much dependent on the non-renewable energy sources such as coal, petroleum, natural gas, that we have depleted them to an extent that now we are in a condition that they may end in the coming decades, or in the coming years. It may deplete and we are in the shortage of energy resources. Okay. And another problem with the non-renewable energy sources is, as we all know, is they are creating problems for the climate. Okay, they are creating pollution problems. Then, as we can see clearly, due to which climate changes are huge, seasonal changes are there. Then, we as humans are facing various health issues. So all that is associated with the pollution related issues, which is associated with the usage of our various non-renewable energy sources. Okay. So with that, the government from various countries, various nations, they are planning and they are making policies in the direction of shifting our focus from non-renewable energy sources towards the renewable energy sources. So, what are these renewable energy sources? Along with the non-renewable energy sources, there are various sources of energy which are available in the environment, which are endless. Mean we can get which are endless. There is no end to them. Like solar energy is there, wind energy is there, then hydro energy, geothermal energy, nuclear energy. So government is asking us to shift our focus from these non-renewable energy sources to this renewable energy sources. What will happen if we use but the problem with this renewable energy sources, it also has a problem, is that it is not available at all places and at all times. For example, if you take the solar energy, it is available only during the day. For example, if we take the wind energy, it is not we cannot exploit the wind energy at all the areas. Like we cannot install wind panels in the middle of a society. So all these renewable energy sources, they have their own limitations, like they are not available at all places at all times. So for that purpose, what term comes into light, we this this term energy harvesting and energy storage term comes into light. So what is energy harvesting basically? Anyone?
Ma'am, energy capturing and use.
Okay. So energy harvesting is basically, it is the generation of energy from these renewable energy sources. It is basically taking the energy, the nascent form of energy these renewable energy sources are providing us, and then converting them to a convenient form of energy which can be used. Okay. For example, from the sun only gives energy in the form of heat and light. But if we, but mainly, but we want to use it as electricity in our in our households, in our daily life. So what we need to do, we need to convert this light and heat energy into electricity. So that basically comes under energy harvesting. Okay, but only energy harvesting is not enough. If we convert it into electricity, we can only get electricity during the day. What about the night time? So for the night time, what we do when we generate this electricity from heat and light energy, we need to store this energy for further use also. So along with the energy harvesting, energy storage is also very important. So what we do, we generate electricity from the renewable energy sources through energy harvesting, and then store them for further use through energy storage techniques. Okay. So coming on to the first term. So basically, this course is related to the selection of nanomaterials which are involved for energy harvesting and energy storage. So basically, what are nanomaterials? So nanomaterials are the materials which are basically there are various materials which are employed during energy harvesting and energy storage. But nowadays, nanotechnology is becoming very is gaining interest. Why so? Because the bigger materials, like the materials in the micro scale or much bigger scale, the amount of energy can help, they can help in producing energy. But if we decrease the size of these materials to nanoscale, what will happen? The surface area of these materials will increase, which will further increase its properties to tenfold. Okay, not only a single property, like we cannot say like it will increase its thermal property only or mechanical property. In the case of nanomaterials, the properties are increased to much higher extent. Basically, all kind of properties can increase depending on the nanomaterial that you are using. Basically, these nanomaterials are used in various applications. Like it is also used to increase the thermal conductivity, also used to increase, some nanomaterials are used for increasing the mechanical property, some are used for the increase of the electrical property. So depending on our application, like what application is required, depending on that, there are various nanomaterials which are used nowadays in for the development of technology for energy harvesting and energy storage. That we will discuss further, what kind of nanomaterials are used in what kind of energy harvesting or storage technique. Okay. So coming on to the nanomaterials, what are nanomaterials? They are commonly materials with which has at least one dimension less than 100 nanometer. Basically, nanomaterial, why this nano term is here? It is just a second. Just a second, guys. I need to change it. So basically, nanomaterials, what does this nanomaterial mean? This nanomaterial basically is nano word is basically the scale related to scale. So basically, it is all the materials. If normally materials they have different dimensions. Okay, so if at least one dimension of a material is less than 100 nanometer, basically in the scale of 1 to 100 nanometer, then we can say that it is a nanomaterial. Okay, you might have heard in the case of nanomaterials, like you might have heard 0D, 1D, or 2D. So what are these? They are basically dimension. D is basically dimension. So 0D is basically it is a particle. So basically, it means like all the dimensions of the particle is in the nanometer range. Whereas in the 1D, it means that one dimension of the particle or the nanomaterial is in the micro range. Or 2D, it means that the two dimensions of the particle or the nanomaterial is in micro range. Okay. So 0D, 1D, that D means the dimension of the particle. Okay. So the nanotechnology, what is nanotechnology? It is the creation of different functional materials or devices by controlling the dimension in nanometer range. So that technology in which the creation of different functional materials or devices and systems are involved by controlling the by controlling the matter in the nanometer scale, then that is involved, that comes under nanotechnology. Okay, so why nano length scale, as I was asking? So basically it is that if we pattern the matter on a nano scale, it is possible to vary its fundamental properties. As I told that the fundamental properties of the material, they change, mean they increase many folds if we decrease the size of the particle to nanoscale. Why so? Because it will increase its surface area, and due to which its properties will increase manifold. Okay, so right now, currently in the research field, nano technology is used in various applications. Basically, nanomaterials are used in all kind of applications in our daily life. Basically, as here we can see, in supercapacitors also they are used in solar panels for generating the electricity from the sun, then for storing of energy in supercapacitor and batteries, then electromagnetic harvesters, triboelectric smart skins. All this we will all these type of energy harvesting and storage techniques we will study further in the course. Okay, so all these type of energies harvesting and storage techniques find application in have these applications find are basically developed using nanotechnology. Okay, so what is energy? Energy, it is basically power which is derived from the utilization of physical or chemical resources. Basically, different resources, the power which we derive from various resources. Resources here mainly energy resources, basically the renewable and non-renewable energy. Whatever power we are gaining from these renewable and non-renewable resources to provide light, heat, or any form of any form of energy, any form of power. Basically, like it may be light, it may be heat, it may be electricity, to do some kind of work, like to run a machine or to light up a bulb. All that comes under energy. So basically, here in this course, we will be studying two uh, concepts: energy harvesting, as I told, and energy storage. And the difference I already told, energy harvesting is basically conversion of energy to a usable form. Basically, uh, getting energy from in one form and converting it to a more convenient form. Basically, for example, from the solar energy, you get heat and light and convert it into electricity. That comes under energy harvesting. Okay. Whereas in the energy storage, it is mainly to store the energy generated here for further use. We use techniques for that come under energy storage. Okay. So energy harvesting has various techniques. Various energy harvesting are of different types, like solar energy harvesting, hydrogen energy harvesting, then nano generators, and various other conventional energy harvesting techniques are there. And in energy storage, electrochemical energy storage in form of batteries, supercapacitors, hydrogen storage, then thermal energy storage is there. All these techniques we will be studying in brief further. Okay. Coming on to energy harvesting, as I told, it is energy harvesting is also known as power harvesting or energy scavenging. Okay, it is a process which is capture small amount of energy that would otherwise be mean basically there are energies available everywhere in the atmosphere, okay, in the form of solar energy or wind energy or hydro energy or geothermal energy. So there is a lot of amount of energy which is wasted here and there in small form everywhere. Some amount of energy is being wasted, okay. So if we capture that wasted energy, that would be lost as heat, sound, vibration, or any kind of energy, and we store them for small wireless, and we store them and convert them into some form of usable energy that comes under energy harvesting, okay. So they typically generate small amount of energy from several microwatts to several milliwatts. There are different range of energy that can be generated from various kind of energy sources, okay. So the main advantage of energy harvesting, it is self-sustainable, unlimited usage is there since we are trying to harvest energy from the renewable energy sources. Then mobility and and promote truly autonomous. Then environmental friendliness is there since it is not exploiting the like it is not producing, it is not causing pollution and climatic harm. Then suitable for numerous deployment at unreachable location at at various locations where there is no possibility to provide energy there. Also solar energy, hydro energy kind of energy sources are still present. So accessibility of energy to remotest areas will also be possible if we try to exploit these renewable energy sources, okay. Then application, there are various applications of these energy harvesting, like charging of electronic devices, then remote area sensing, industrial automation, lifestyle management, such various energy resources and that applications are there, okay. Now coming on to the solar energy harvesting. So basically the amount of as we know that sun is a like endless source of energy. It provides energy to the earth in the form of heat and light. So the amount of energy which is supplied to the earth in one day by sun is sufficient to power the total energy need of the earth for 1 year, okay. So the amount of energy we are receiving from sun in one day, it is enough to to fulfill the power needs of earth for almost a year. So you can think that how much amount of energy we are getting, and how much, like, on one side we are saying that we are in an energy crisis, but we have such a huge and endless source of energy. So would it not be fine, would it not be great that if we try to capture and try to store this energy instead of running towards the non-renewable energy sources, so that we will be discussing further. So it is a process of capturing and storing solar energy which is radiated from the sun. It is basically solar energy harvesting is, it is nothing, it is just we are trying to gain the energy which is given from the sun in the form of light and heat, and trying to capture it and store it, which comes under solar energy harvesting. And it is then this light or heat energy, it is converted to electrical energy by suitable means, okay. So why solar energy? It is the answer is very simple, that solar energy is free and it is silent and no mechanical parts are required. Then almost maintenance free. And there are so coming on to the main concept of the course, that what kind of nanomaterials are used in solar energy harvesting. So there are different kind of solar cells which are used nowadays, and depending on that, nanomaterials change. So basically in dye sensitized solar cells, we use CDT, that is cadmium telluride, then CDS, cadmium sulfide kind of nanomaterials. Then perovskite uses CH3NH3 PbI3 kind of nanomaterials, zirconium oxide, titanium oxide. Then solar thermal storage plants use copper, nickel, manganese, spinel, composite, etc. Okay. So these kind of nanomaterials are used. Basically, nanomaterials, they change according to the application that is required. Okay. Suppose where we need to increase the thermal conductivity of a material. They are different kind of, for example, in the solar energy harvesting only we can take that we need nanoparticles or nanomaterials which can store a large amount of heat. Okay, so for that purpose, we need to choose nanomaterials which have higher thermal conductivity. For example, in other cases, for example, in supercapacitors, we need better charge storage. So we need to choose nanoparticles that have good electrical conductivity or good electrochemical uh, properties. So according to the requirement, nanomaterial changes. Okay. Then coming on to the hydrogen energy harvesting. Hydrogen, as you might have heard recently, hydrogen is becoming very famous. So this hydrogen, it is the simplest and most abundant element on the earth. Okay, pure hydrogen, it is not found in free in the nature. Basically, in the simplest form, where we find hydrogen in water, two atoms of water are present in two atoms of hydrogen are present in water. So if we separate out that water from separate out the hydrogen from water, then we can use that hydrogen as pure fuel. Okay, so there are different techniques which are used for the hydrogen energy harvesting, which we will be discussing further in detail in the coming weeks. So here I am just giving a small gist of whatever energy harvesting, what different kind of energy harvesting techniques are there. So we will be only discussing this in the introduction class, and focusing on solar energy harvesting. Apart from that, and other energy harvesting and storage techniques we will be discussing in the coming weeks. So here, pure hydrogen is not found free in nature, but found mainly as water or natural gas. And lower concentration and some amount of hydrogen is also present in biomass or fossil fuels and other hydrogen-containing compounds. So basically, how hydrogen energy harvesting helps? There is this device which is called a fuel cell. It converts the chemical energy into electrical energy. Basically, what happens? It combines hydrogen and oxygen to produce electricity, heat, and water. Okay. So nanomaterials which are used in hydrogen energy harvesting, it is Y2Ti2O7 or K2Ti2O5. Then indium nitride, indium gallium nitride quantum dots. Then carbon doped titanium oxide, iridium oxide is also used. Titanium oxide is used. Platinum is used. Okay, so there are various nanomaterials which are used in this hydrogen energy harvesting. Okay, and different methods of hydrogen energy harvesting, it is basically solar hydrogen production, then fossil fuel and biomass, then from the thermochemical processes also we can produce hydrogen, and the most famous right now currently it is the electrolysis, basically the electrolysis of water. Basically by splitting the water we can separate the hydrogen atom from the water atom, and from that this is currently the most famous technique which is currently being focused since uh, so this is the most famous technique currently used in the for the hydrogen energy harvesting. Okay. Now coming on to the nano generator. So what is the nano generator? It is a basically it is not a generator in a nano scale. Basically the generation of electricity from nanomaterials. Okay. So there are some kind of nanomaterials which can help in the generation of electricity. Basically what happens here, it converts the mechanical or thermal energy which is produced by small scale physical changes into the electricity. For example, there are some kind of nanomaterials, if we tap on them, then that pressure or contact is producing energy. Okay, for example, there are different types of nano generators. Piezoelectric nano generator is there. Triboelectric, like piezoelectric, basically by rubbing or by contacting two different materials, we can generate electricity or generate power. Then triboelectric nano generators, pyroelectric nano generators. Basically, pyro means heat. So nanomaterials, there are some nanomaterials. If we provide heat to them, then they can produce electricity. Then thermoelectric nanogenerators are there, electromagnetic nanogenerators. All this we will be discussing further during the lecture of nanogenerators. Okay. In short, we can discuss here the piezoelectric nanogenerator. It is an energy harvesting device which is capable of converting external mechanical energy into electrical energy via action by a nanostructured piezoelectric material. Basically, I'm talking about there are some kind of nanomaterials. What we do if we that material have piezoelectric effect. Basically, it generates electricity when stress is applied. So, if we apply a small amount of minor amount of stress to the material, that piezoelectric material, what will happen? This it will convert this stress into electricity. Okay, so the generation of electricity is there when stress is applied, and sometimes vice versa also takes place. The generation of stress when an electric field. If you apply an electric field to that material, then stress will be generated. Okay. So piezoelectric energy, it is basically the ability of certain materials to generate an electric charge in response to a applied mechanical stress. Okay. So different kind of nanomaterials are used in piezoelectric nanogenerators. For example, zinc oxide nanorods, then cadmium sulfide, then gallium nitride, then BaTiO3 nanowires, etc. Okay. Coming on to the triboelectric nanogenerators, the triboelectric effect is a type of contact charging effect. Basically, if you rub two materials together, two sheets of material together, they have distinct triboelectric charges, mean characteristics. Means if suppose we rub two different materials, two sheets of different materials together, then one will gain electron and other will lose electron, creating two different charges on the two different plates of the sheets of the material, due to which charge generation will be there, charge separation will take place, and charge flow will take place. So the working principle of Tang, it basically is dependent on the coupling of charge electrification and electrostatic induction. So basically, if you rub two different sheets of material together, then charge generation will take place on those two sheets and charge separation will take place, which will further help or assist in the generation of electricity. Okay. Almost any material we know that triboelectrification effect, there are various nanomaterials which are used in triboelectric nanogenerators. The short form for triboelectric nanogenerator is TENG. So basically, there are various materials that are differing from metals to polymers to silk, then to wood, and then nanomaterials like CNT, that is carbon nanotubes, graphene oxide, silver nanowires, they all can be used as fillers for fillers in triboelectric nanogenerators to produce uh, electricity. Okay. Then the next one is pyroelectric nanogenerators. Where is basically pyroelectric nanogenerator, it is a energy harvesting device which converts the external thermal energy into an electrical energy. Okay. Pyro, basically here we can see pyro means heat. So if it is basically converting the thermal energy into electrical energy by using nanostructured pyroelectric material. Okay. So pyroelectric crystals are the materials which when heated, the atomic structure changes. Okay. So there are some kind of materials which are pyroelectric crystals. If we apply heat to them, then the atomic structure in them changes, and due to the change of this atomic structure, they exhibit a potential different at both end of the materials, due to which the whole crystal is changed from one temperature to another, and the result is a temporary voltage across the crystal. Okay. So the pyroelectric effect creates a temporary voltage when the temperature changes, whereas the thermoelectric effect. So another technique is the thermoelectric nanogenerator. So what is the difference in both of them? You will say that here also temperature is there involved, then here also temperature is involved. But the difference is that in the case of pyroelectric effect, only temporary voltage change is induced. Whereas in the case of thermoelectric, permanent voltage change is induced when when there is a temperature gradient. Okay. The nanomaterials used in the case of pyroelectric nanogenerators is
these HTF. So basically, this
KNBO3
is good
nanowires
for
with
exchanging the heat from one
PDMS.
system to
PDMS is
another.
basically
Now we have come to the last part of this particular lecture. So in
polydimethylsiloxane
summary, we can say that
polymer.
heat transfer
Then
fluids needs
zinc
to collect,
oxide
transport, and
nanowires,
exchange heat
PZT
obtained from
nanowires
solar
are
radiation.
used as
Heat transfer performance
nanomaterials
of
in
HTF can be
pyroelectric
enhanced by adding
nanogenerators.
high thermal
Okay.
conductivity nanoparticles
So
to the base
coming
fluid.
on to the
Nanofluids can be
thermoelectric
synthesized by one-step
nanogenerators. So
method or maybe the
thermoelectric
two-step method.
nanogenerators,
Controlling the
also
surface charge
called as
of the
a
nanoparticles using
Seebeck
ultra
generator,
solvations,
as
adding
it
surfactant makes
works
the
on a
nanoparticles stable
Seebeck
in
effect.
base fluids.
So
Also, it
basically, it
will
is a solid
make a
state
barrier
device which
in between
converts
the
the
agglomeration of the
heat
nanoparticles.
flux directly into
Collisions between the
electrical
nanoparticles
energy
leads to
through
energy exchange among the
Seebeck effect. Okay, so what happened? Heat is applied in one side of the couple and rejected from the other side. At atomic level, what happens? An applied temperature gradient causes the charge carriers in the material to diffuse. So what happened when we apply a temperature, or when we apply heat at atomic level, this temperature gradient causes the charge carriers to diffuse from the hot side to the cold side. I mean, it induces a motion of charge carriers from hot side towards the cold side, thus inducing a thermal current. Okay. So nanomaterials used are the Bi to Te3 nanorods, then polyaniline nanoparticles, then lead telluride or lead telluride it is like selenide. Then quantum dots are used. Then bulk nanocomposites are used. Nanocomposites, what are these? Nanocomposites are basically the mixture of more than one nanoparticle. So they are basically called the nanocomposites. Okay. Coming on to the electromagnetic generators work on the principle of electromagnetic induction, on which works on the principle of Faraday's law of induction. So electromagnetic harvesters use a spring mass system to convert the energy. When the spring is set in motion, vibration takes place, and this vibration is converted into electrical energy. Okay, so the mechanical motion of the mass is converted into electrical energy by electromagnetic coupling between the magnets attached to the mass and stationary coil. Okay, we will be studying all these techniques in detail in the upcoming classes. That's why I'm giving a brief introduction only, because in this lecture we will be discussing the solar energy. Okay, so the electromagnetic harvesting systems have lower production cost and longer lifetime. And the nanomaterials used are the samarium cobalt, then neodymium, iron boron, etc. Okay. So other energy harvesting methods, as I told, that wind energy is also a vast source of renewable energy sources. So wind is caused by the uneven heating of the atmosphere by the sun and vibration in the Earth's surface and rotation. So basically, wind panels are mainly installed near the areas where there is the wind velocity is very high. So it is sometimes it is mostly it is installed in the seashore areas. So what happens? Seashore areas or mountains or near the water bodies. So what happens? How wind flows. It flows due to the uneven heating of the atmosphere by the sun. So what happens? For example, let's take an example of seashore. What happened? That on the shore side, mean on the on the beach, there is the water heating takes place in the ocean, and the air above that water also gets heated, whereas on the shore side there is no heating. There is a different amount of heating of the air above the shore. So the difference in the temperature of the air allows the motion of the air. Okay, increases or decreases the velocity of the air of the wind, due to which these panels move, and this propeller in the turbine of the wind panel moves, and this wind turbine converts the energy in wind to electricity by rotating the propeller like blades along around the rotor. And rotor turns the drive shaft, which turns on the electric generator, and where the energy or electricity is generated. Okay, so the nanomaterials used in wind energy, where these nanomaterials must be used on the surface of these wind turbines. So basically, why on the surface of the wind turbine nanomaterials or nanoparticles are required? So because these wind turbines, they are installed in in a very in open atmosphere, and they're continuously moving. So there are chances of corrosion chances are there. They're also working in the rainy season, in the summer season. So they are continuously facing harsh conditions. So to prevent all the side effects, if it comes into the presence into the contact of rain or moisture, then corrosion might take place, then different other problems might take place. So to prevent those, we must use nanoparticles which can prevent all this. So basically, for that purpose, nanoparticles are used in the coatings of these wind turbines. Okay, so the nano composite high strength carbon nanofibers are used for the as nanomaterials in these wind turbines. Just a second. Okay. The another form of energy is tidal energy. So tidal energy, it is similar to hydroelectric power as it makes use of moving water to spin a turbine. So tidal energy, basically we are trying to harness the energy which is coming from the moving water, which is at the seashores. Basically this tidal energy, it can be harnessed at the seashores. So what happens at seashore, waves are created, like tides are created. So water at a very high speed comes and helps in the motion of these turbine blades, and these turbine blades further in helps in the motion of the further helps in the generation of the electricity. So this tidal energy, basically it is similar to the hydroelectric power as it makes use of moving water to spin a turbine to produce electricity. So, as tide rises and falls due to gravitational pull of the sun and moon, water flows through the mouth of these bays and other narrow areas. And as the tides are generated by the ongoing movement of the planet, tidal power is considered renewable energy sources. It is also renewable energy sources since it is also controlled by the since it is taking place due to the tides, which are mainly occurring due to the rise and fall due to the gravitational rise and fall of water due to the gravitational pull which is occurring from the due to the sun and moon. Okay, so the nanomaterials here also anti-corrosive corrosive coatings on turbines is required, which involves nanomaterials like tungsten carbide or cobalt mixture. Nano composites can also be used. Single nano particles can also be used. So the coatings for these like turbines is done with using these nano materials. Okay, to to resist corrosion. Okay, so the geothermal energy, another is geothermal energy. So what is geothermal energy? It is basically the energy which comes from two sources. Basically, one is the radioactive decay which is happening in the deep down the crust of the earth, and other is the heat which is trickling through the mantle. Another, the one is the all that radioactive decay which is happening deep down the crust of the earth. Some amount of heat is generated, huge amount of heat is generated at during that radioactive decay also, and other is the heat which is coming from the mantle of the earth core. Okay, so simply what we can do, how we can exploit this, it is an attractive renewable energy source, and it is always on and dependent on the and it is independent of the weather. Obviously it does not depend on any kind of weather, and it is always present. Okay, so the higher temperature fields which are located geodynamically in geodynamically active regions with temperatures above 250 degrees C can be utilized at high temperature. What we do, we simply can do is by inserting a tube, and using that tube we can insert some kind of liquid which will be heated up, and we will get the heated liquid from here, and we can exploit the heat which is trapped into this liquid for generation of steam, and further this steam is used for the rotation of the turbines and generator to produce electricity. There are various kind of liquids which can be used during this. Here it is shown hot water. I mean, we can use water also, and there are, I mean, different other liquids can also be used depending on the heat capacity of the depending on the heat capacity of the liquid. Okay, so nanomaterials here that can be used are the graphene, CNT, copper oxide, aluminum oxide. All these nanomaterials, they are used to improve the thermal properties of the fluid. Here, where we are using nanomaterials, we are using nanomaterials within these liquid. So What kind of nanoparticles are required? Nanoparticles which may improve the thermal property of the fluid. Thermal property like heat storing capacity of the fluid. So if the heat storing capacity of the fluid is more, it will accommodate more heat from the geothermal sources and will give more heat out of, for the generation of the electricity. Okay. Next is the thermal power plant energy. So basically the power plant, it is the generation of thermal energy. Basically it is generating the electricity from heat. So here heat energy is generated by burning some fuels. So the problem with this type of thermal power plant energy is that it is not coming from the renewable energy sources. So basically it is not that encouraged, since it is using the heat which is generated from the fuels, basically like fuels like fossil fuels, coal, oil, gas. So this is still used, and it was mainly used in the in the ancient times, when the only source was when the only source for generating electricity was non-renewable energy sources. So basically what we used to do, what was done, we the fuel was burned, and the heat which was generated from the burning of these fuels was used for the generation of electricity. Okay, so as it is given here, when coal is burned to produce heat energy and it is used to create steam, this steam drives the steam turbine which is connected to a generator, and the energy produced by the generator is passed through a transformer into the grid transmission line. Okay, so the nanomaterials which are used in the thermal energy generation is CNTs, lithium zirconium oxide, and they are basically used to absorb the CO2 gas emitted from the thermal power plant. So here during the burning of this fuel, what will happen? Huge amount of carbon dioxide gas will be emitted, which is obviously not good for the environment. So to absorb that carbon dioxide, different kind of nanomaterials are used, so that it can decrease the carbon footprint of the this thermal power plant energy. Okay. Then coming on to one another energy source, that is the nuclear energy. Basically, nuclear reactions deal with interactions with nuclear reaction takes place, and those nuclear reactions helps in the generation of electricity. That is called the nuclear energy. So the nuclear reaction deals with the interaction between the nuclei of atoms, including there are two types of reactions which takes place, that is the nuclear fission and nuclear fusion. So fission, it is basically the splitting of a nucleus into two daughter nuclei, and fusion is basically the fusion of two parent nuclei into a one daughter nuclei. Okay, and both these techniques, both these processes release energy, and that energy can be used to generate electricities, as we can see here that the energy released during the nuclear fission or nuclear fusion is used to heat the liquid in these coils, and this liquid which is heated, it produces steam, and then steam helps in the rotation of the turbine, and further this helps in the helps the generator to produce electricity. Okay, so the nanomaterials, nanocrystalline manganese gallium oxide is a radiation tolerant for absorption of radiation. This nanomaterial is used. Then copper oxide, aluminum oxide, graphene oxide, CNTs, they are used for the they are used as nanofluid for cooling. Okay, so there is huge amount of that heating is generated during the nano fission and nano fusion. So if that heat generation increases up more than a fixed extent, what will happen? It may lead to fatal accidents. So controlled heating of the reaction is required, due to which there are various nanofluids which are used to for the cooling of the system of the nuclear reactors. Okay, then coming on to the energy storage, it is the capture of energy produced at one time to use it at a later time. As I told that these renewable energy sources are not available all the time, so we need to store this energy for further use. Okay, so a device that stores energy is, it is basically called an accumulator or battery. So basically the most basic device which we have heard about for energy storage from our childhood, that is a battery. So some technologies, they provide short term energy storage, while others can endure for longer time. Okay, there are various methods for energy storage. there are different devices for energy storage, that is the flywheel energy storage, then supercapacitors, batteries, thermal energy storage, and hydrogen energy storage. Okay. Then coming on to the electrochemical energy storage, it is basically a method to store electricity under a chemical form. Okay, so the batteries come under electrochemical storage. What happens is the energy storage here is done, electricity is produced by a chemical reaction. Okay, by doing a chemical reaction, we are trying to generate electricity. Okay, which we will be discussing further then in detail. Then batteries, they are basically of two types, as we know, primary batteries and secondary batteries. So what are primary batteries? The batteries which are mainly, you might have seen in the remote controls, we use a battery. That is a single time use. Mean we fabricate the battery, then we charge, then it is provided to you in a charge state, then you use it, it gets discharged and you throw it away. So it is a single time use battery. Okay. Then another is the secondary battery. So what is secondary battery? It is basically rechargeable battery. Basically you can use it, you can charge it at your home, then you can use it, it gets discharged and then you can charge it again. So basically the batteries which are present in our like mobile phones, then uh, laptops, all these are rechargeable batteries. Okay. So batteries convert the electrical energy contained in its active material into electrical energy by an electrochemical oxidation reduction reverse reaction. Okay. So nanomaterials used in electrochemical energy storage is there are various kind of nanomaterials which are used in in batteries. So they are mainly used as electrode materials in the battery. That is the anode materials. For anode material, CNTs, that is the carbon nanotubes are used. Then tungsten sulfide nanotubes. Then titanium disulfide nanotubes, titanium oxide nanotubes, then FeSNO2, SN2, then Cu6SN5. All these are used as the anode materials. And for cathode, that is the vanadium pentoxide, then different like compounds of lithium, that is LiFePO4, LiMn2O4, LiMnO2, then LiCO2, that is lithium cobalt oxide, which is these type of materials are used as cathode materials. These nano materials are used in batteries for as cathode materials. Okay. Then coming on to the supercapacitors, it is another energy storage device, which are electronic devices which are used to store extremely large amount of electrical energy. Okay. So instead of using a conventional dielectric capacitor, nowadays supercapacitors, they use different three types of mechanism to store energy. The first one is double layer capacitance, then pseudo capacitance, and then the hybrid supercapacitor. Hybrid supercapacitance, that is basically a combination of these two, that is the EDLC and pseudo capacitance, a combination of both two uses to give a hybrid supercapacitor. Okay. In a supercapacitor, there is no dielectric between plates. Instead, in nowadays supercapacitors, there is no dielectric place between the plates. Plates basically the anode and cathode. Instead, we use a electrolyte and a separator. Separator basically it is a permeable membrane which will allow the passage of uh, like electrolyte ions, but prevent the direct contact of both the anodes to prevent short circuiting. Okay, so nanomaterials which are used in supercapacitor, they are basically graphene, manganese oxide nanocrystals on graphene oxide nanosheets, then ruthenium oxide, etc. And there are many more such nanomaterials which are used in supercapacitors. Okay. Then hydrogen energy storage. Hydrogen can be stored physically as either as solid, liquid, or gas. So basically, hydrogen storage is a big problem. So nowadays, it is tedious research is going on to for the storage of hydrogen energy. So basically, scientists what they are thinking that if it is possible to store hydrogen in a solid form, then it would be very convenient. But it is very difficult to do so. So the tedious research is going in the field of hydrogen energy. Okay. So the storage of hydrogen as a gas typically requires a high pressure tank of 350 to 700 bar tank pressure. So, it's a huge amount of pressure. Storing a gas at such high pressure, it is very difficult and it is a very risky process also. So, the storage of hydrogen as a liquid require cryogenic temperatures because the boiling point of hydrogen at atmospheric pressure, it is minus 253 degrees C. Hydrogen can be stored on the surface of the. Another form is that we can also store hydrogen on the surface of solids or within the solids by adsorption or absorption. Okay. So now different kind of nanomaterials used in hydrogen storage, hydrogen energy storage. They are the CNTs, that is carbon nanotubes, then metal organic framework, then metal organic framework. Here M is basically different metals, that is magnesium, manganese, iron, nickel, copper, zinc, and then graphite carbon nanofibers. Okay. Then thermal energy storage, it is basically the thermal energy storage can store heat or cold to be used later. So basically, it is here thermal energy storage. It is basically particularly it is used in building and industrial processes where if there is some amount of generation of heat, then we can exploit that heat instead of wasting that heat. Okay, so the thermal energy storage systems can store heat or cold to be used later under varying conditions such as temperature, place, or power. So thermal energy storage involves three steps. It is basically three steps are involved in thermal energy storage, that is the charged, storage, and discharge. So TS system for a particular application depends on storage duration. Mean this system, it is basically storage of energy not only in the form of heat but also cold. I mean, if some amount of energy is generated somewhere or it is wasted somewhere, then suppose if you are using, for example, solar energy, we need to exploit. Okay, so if we are focusing, suppose we are focusing solar energy onto a receiver, and then receiver is focusing solar energy onto a tank of water where that water is getting heated. So we can use some amount of water, water is getting heated and generating steam, and that steam is used for the generation of electricity. So it is possible that some amount of heat is also wasted there. So storing or capturing that heat wasted there is that comes under thermal energy storage. Okay, so there are various nanomaterials which are used in thermal energy storage. Basically, that is the copper oxide, aluminum oxide, or multi-walled carbon nanotube, or exfoliated graphite nanoplatelets, and many more nanomaterials uh, can be used depending on the requirement. So now coming on to the solar energy, we will be talking about solar energy in detail. So what is solar energy? We all know solar energy. It is basically the energy that we are getting from the sun in the form of light and heat. So how solar energy is forming? It is a form of energy which relies on the nuclear fusion. So basically, you might know that the solar energy comes from the nuclear fusion which is taking place at the core of the sun. Okay, so, as an hour of solar radiation on the Earth provides 14 terawatt years of energy, which is almost the same as the world's total annual energy consumption. So, only 1 hour of solar radiation can provide us with the energy up to the total, which can cover the total annual energy consumption. So, you might imagine how, what a huge amount of energy we are getting from the sun. Okay, so solar energy is a free, inexhaustible resource, yet harnessing it is a very new idea. Okay. Why so? Because it is not simply like we get the heat and we it is not so simple. Like harnessing solar energy is not like very simple. It is not like you keep a bucket of water and let it heat and you can generate electricity from that hot water. It is not possible. Only that can be used, that is also saving energy only, like instead of using geysers we can simply keep a bucket of water in sunlight and it gets heated in some time. But that is a very simple form of utilization of solar energy. To use this solar energy in very complicated systems and to generate proper amount of electricity, to provide energy on a large scale or electricity on a large scale, it requires lot of system and management and basically lot of mechanical machinery. Okay. Then why solar energy? As I told you, till now we were using non-renewable energy sources, which are definitely we can see are creating a lot amount of climatic hazards, that pollution issues, then uh, which also comes with the human health issues. So there are various problems that is associated with the using non-renewable energy sources. So that is why we need to shift towards the solar energy. Okay. So the most advantage using solar energy is that this is distributed, and one of the other most important advantage over non-renewable sources is that it is available all over the earth. Okay, there is not like coal; it is not available at all places. It is localized to some of the geographical areas. But in the case of sun provides sunlight to the to each and every nook and corner of the earth. So that is also an advantage of this solar energy. Okay. Now, importance of solar energy. Basically, the solar energy, this table shows that the amount of carbon and sulfur which is deposited in the atmosphere due to the usage of various non-renewable energy sources. So all these like usage of vehicles and waste products, then fossil fuels, then deforestation and forest firing, all these is creating it is all depositing various hazardous elements in the atmosphere, whereas at present so many alternate fuels have been developed, still they are able to meet only a small proportion of our actual demand. Okay, so basically what we are saying here is that we need to replace these non-renewable energy sources with the renewable energy sources, which is becoming a very crucial and uh, topic of emergency right now. Okay, so this is a data which is it is a data from Ministry of Renewable Energy Sources, which is showing here that most the largest source of energy that is largest source of energy in the world right now is the coal. So it is covering almost 56.23% of the total energy generated, and up after that comes the renewable energy sources. Okay, which is 21.41, and from the renewable energy sources also, solar energy comes at second place. First one is the wind energy. So here we are trying to say is that solar energy is covering a very huge part of energy production spectra. So if we try to convert or try to harness this solar energy, the problem of this energy crisis is handleable. It is controllable. Okay, so the advantages, there are various advantages of solar energy. Basically, the advantages involves after the initial investment, the energy from the sun, it is practically free. And for that purpose also, since initial investment is required, actually there is a huge initial investment is required for solar energy production. So for that purpose, government is also providing financial aid in different forms, in the form of subsidy or incentives. Government is providing financial aid so that we can try to shift from the non-renewable energy sources to renewable energy sources. Okay, so the solar energy, it is clean, renewable, sustainable, and helping to protect our environment. Then once installed, there is no recurring cost. Mean after installation, there is mean no other cost, which is no extra cost which is involved in the production of the solar energy. Okay, and they operate very silently, have no moving parts. Apart from that, it also has few disadvantage. The one I have told, that is the initial cost is the main disadvantage of installing a solar energy system. Then solar panels, it requires large area of installation. So for installation of the solar panels or solar system machines, it requires large area. Okay, so to achieve good level of efficiency, meaning if you require large production of means suppose if you want to sell electricity produced by the solar energy, so it is not possible like you install one two panels or 8 or 10 panels, then you can and you can sell. For that purpose you need to install a huge amount of solar panels to get a good efficiency. For that purpose, large area of installation is required. Okay, so the following are the different coming on to the classification of solar energy. Okay, solar energy are of two types, that is the passive and active. And the active is of further divided into solar thermal and photovoltaics, and then solar thermal is of concentrated solar thermal type, and photovoltaic is of crystalline and thin film type. Okay. So we will be discussing. So what is passive solar energy? Passive solar energy, it is a method in which no mechanical machinery is required, no external device is required. So mainly, for example, uh, drying of your clothes. So you are using solar energy for drying of your clothes, okay, but there is no external machinery is required. You are simply hanging your wet clothes in the sun and your clothes are getting dried up, okay. So that is the simplest example of passive solar energy. Another is, if suppose you keep a bucket of water in sun for heating up, after sometimes the temperature of the water rises, that is a simplest form of using the heat energy from the solar energy. Mean basically in the form of, for example, instead of using a geyser, you are simply keeping a bucket in that in sun. So that is without the usage of any external machinery. So that is the passive solar energy, where there is no without any mechanical device. Okay. Then coming the active solar energy. The active solar energy employs mechanical or electrical equipment for functioning and increasing system efficiency. Okay. For example, water pumps are used to circulate water through the active solar energy water heating systems. For example, here, this is suppose it is a active solar space heating. So what happened? Sun will be heating this panel. This is the solar panel. Sun is heating this panel. Air is flowing inside this panel, and when the falls onto this panel, this air gets heated up, and this hot air here up fan is attached, which is sucking this hot air into the room. So this solar space heating system can be is it is employed during the winter seasons for as blower. Okay. Then this here, it is active solar pool heating. So here what we do, simply the swimming pool water, it is flowing from this solar panel, and as sunlight falls over it, the water in this flowing in this panel gets heated up, and hot water gets returned to the pool. So here a little amount of mechanical machinery is involved. Okay. In this previous case, there is no mechanical machinery is involved, like heating of clothes or anything. No mechanical machinery is involved. But here in this case, mechanical machinery is involved. That is why it is called the active solar energy. Okay. Then the type of active solar energy, the first type is the solar thermal energy. Solar thermal power generation collects and concentrates sunlight to produce the high temperature heat needed to generate electricity. So simply solar thermal energy, what happens is, it is basically in the solar thermal energy, it collects what is done here. Simply what the sunlight is focused to a collector, and this collector basically some kind of liquid or heat transfer fluid is there in the collector, which gets heated up, and then this heat is uh, is used for the generation of electricity. So directly here, in this case, so here directly heat is not generated. Solar energy first is captured as heat energy, and this heat helps in the production of steam, which is helps in production of electricity. Okay. So that is solar thermal energy, which we'll be discussing in detail. All solar thermal power plants have solar energy collectors with two main components. Two main components are involved here. The first one is reflectors. Reflectors basically mirrors. So sunlight falls on these mirrors. They capture the sunlight and focus this sunlight to a receiver. Okay. So what will happen? Suppose sunlight falls on this mirror. Okay. This mirror, you can change the direction of this mirror. Okay. Depending on the direction of this mirror, suppose there is a receiver. Here it is a receiver. So this mirror will focus all the sunlight to a single point, thus creating a very like uh, a concentration of a huge concentration of sunlight to a single point. For example, you might have seen like in our childhood, we used to concentrate the sunlight to a single point on a paper using a microscope. Okay, so that is the same thing we are trying to do here. This mirror will focus the sunlight to a single point, and what will happen? This receiver in turn will mean there will be some kind of fluid, heat transfer fluid, which will be flowing in this receiver. So when this focused sunlight falls into the receiver, the heat transfer fluid gets heated up, it generates steam, and this steam further helps in the generation of electricity. Okay, so the steam is converted into mechanical energy by turning the turbines, which powers a generator to produce electricity. Okay, then the another one is the photovoltaic solar cell energy, which consists of two or more thin layers of semiconducting materials, most commonly silicon. Okay, so it is a basically this photovoltaic solar cell. It is an electrical device which converts the energy of light energy directly into electricity using the photovoltaic effect. So, what is photovoltaic solar cell? It uses the photovoltaic effect, and it is derived from the Greek word photo, which means light, and voltaic means voltage. Okay, so it is using the light energy to produce voltage. Okay, so the basic operation, it involves basic operation which is involved in the photovoltaic cell. It is the absorption of light, which leads to the generation of electron hole pairs within the photovoltaic material, and then these electron hole pairs get separated, which gives rise to the electrical current which flows in the external circuit. Okay, then the classification of solar cell based on materials. So based on the materials, it is divided into three types. That is the first generation, second generation, third generation. So first generation, it is the monocrystalline solar cell, polycrystalline solar cell. Second generation, it is the amorphous silicon thin film solar cells, and cadmium telluride, cadmium indium sulfide, or cadmium indium gallium sulfide thin film solar cells. Then third generation is the organic solar cell, dye-sensitized solar cells, quantum dot solar cells, and nanocrystalline based solar cells, and perovskite solar cells. So coming on to the first generation solar cells, first generation solar cell, it includes two types, that is the single and polycrystalline silicon solar cell. The first generation, as I've told, monocrystalline and polycrystalline. So monocrystalline basically means single crystal of silicon. Okay, silicon, how this single crystal is generated, it is formed. So silicon, it is melted and then crystallized. Basically, recrystallization of silicon is done into ingots, or casting of pure silicon takes place, and then the thin slice of silicon are cut, which is basically to form a single crystal of silicon, that is monocrystalline. And if we take the whole block of single crystal silicon crystal, that is the polycrystalline. Okay, single crystal and polycrystalline means numerous crystals, more than one crystal, okay, to make individual cells. And the conversion efficiency of these cells ranges from 10 to 20%. Okay, so this is the photo of a monocrystalline. This is how a single crystal of silicon looks like, and this is how the polycrystalline silicon looks like. Then coming on to the second generation solar cells, basically these aims to use less material while maintaining the efficiency of first generation. So here, large amount of material is used, like polycrystalline whole block of silicon is used in the first generation, and its efficiency is 10 to 20%. But in this case, we are trying to decrease the amount of material so that we can use small amount of material and get good efficiency. So in this case, we are trying to do that. So they involve amorphous silicon, cadmium telluride, copper indium selenide, and copper indium gallium selenide. All these materials, they absorb the solar spectrum much more efficiently than the single crystal silicon. So simply here we are trying to tell is that the nanomaterial investigation or nanomaterial research is currently still going on, and it will be going. I mean, researchers keep on working. Okay, and with the what is the main motto of a researcher? What we do is that if we are getting a good result, suppose if we are getting a efficiency of 50%, researcher won't stop there. It will start to work it will start to further increase the efficiency. So the research is currently going on. Each day new kind of materials are getting invented. So after with each material, these nanomaterials, they are
Basically here, as we can see that large amount of crystal is large amount of material is giving only 10 to 20% efficiency. So here we are thinking that this amount of only 10 to 20% efficiency is given, and we have to provide very huge amount of material. Then there is no such mean this is a mean basically it is not profitable. So what we are trying to do, researchers are trying to find new nanomaterials so that small amount of nanomaterial can give good efficiency, which will make the process and generation of electricity from solar energy profitable. Okay, so these all these nanocrystals, they absorb the solar spectrum much more efficiently than single crystal silicon, and they uses very small amount, which is evident here that only 1 to 10 micrometer thickness of the active material is required. So these are the active materials, only 1 to 10 micrometer thickness of the active material is required. Okay. Thin film technology is less expensive since it uses fewer material and less manufacturing process. Okay. So this is the arrangement of different kind of solar cells. Here amorphous silicon layer is used, then here cadmium telluride is used, and here cadmium indium gallium selenide is used. Okay. Then amorphous silicon thin film cells. Coming on to amorphous silicon thin film cells, amorphous silicon has limited short range order, so its physics is completely different from that of the crystalline. Mean amorphous and crystalline, you might guys might know. Amorphous is basically the arrangement of the molecules is random within the molecular structure of the of a material, whereas in the crystalline the atoms or the molecules are arranged in a ordered manner. That is the crystalline. Okay. So in the case of amorphous silicon, it has limited short range order. So its physics is completely different from the crystalline type of amorphous silicon. Okay. A crystalline type of silicon. With the development of nanotechnology, we can see here that it is basically having a homogeneous layer of amorphous silicon to absorb short wave photons. Periodical amorphous silicon nanorod structure. I mean, this is the development of research. Different kind of amorphous silicons were used. Firstly, homogeneous layer of amorphous silicons are also used. Sometimes periodic amorphous silicon nanorods are also used. Then amorphous silicon structure nano cones are also used. I mean, different kind of nanostructure. Basically, in nanomaterials, morphology is different, and morphology is very important. What kind of the morphology of a same, if we change the morphology of a same nanoparticle, suppose here we can see the periodical amorphous silicon nanorods. These are the nanorods and these are the nanocones. So even by changing the morphology, properties of the nano materials changes. Okay. So here is the setup of the amorphous silicon cell, where firstly glass is there, then transparent conductive oxide, then P-type silicon, I-type silicon, and N-type silicon. And here the P-type silicon loses the electron. As the electron is lost, then hole is left. Okay, so electron move towards this direction and hole moves towards this direction, creating a positive charge here and negative here. As so in the outer circuit, current flows in this direction and electricity is generated. Okay. Then in the case of cadmium telluride thin film cells, it is a polycrystalline semiconductor material made of cadmium and tellurium. It is a high light absorptivity level, and only 1 micrometer thick semiconductor can absorb 90% of the solar spectrum. So you can see here that such less amount of material uh, is enough to absorb almost 90% of the solar spectrum. Okay. So cadmium telluride cells have been fabricated by physical deposition. There are different techniques which are used for the fabrication of these solar cells. So these are the techniques, that is physical deposition, spraying, screen printing, followed by sintering and electrodeposition. Okay. So the disadvantage with this is that the only disadvantage with this is that cadmium is a toxic heavy metal that can pollute the environment. So the usage of this cadmium telluride, it is not much advisable. Okay. Coming on to copper indium selenide. It is a polycrystalline semiconducting material and are the most light absorbent semiconductor. Basically, up to 90% of the solar spectrum is absorbed. And if we add a small amount of gallium along with this, it is a multi. It the small addition of small amount of gallium to CIS produces a photovoltaic cell with a higher conversion efficiency. So basically, we can add different kind of materials into the nanoparticles to increase its efficiency. Okay. Coming on to the third generation solar cells, basically they are the solution processable solar cells with excellent potential for large scale solar electricity generation. Okay. So these solar cells are using small molecules like quantum dots, quantum wells, or super lattice technologies. Basically, they are using organic and basically the organic and dye sensitized solar cells are coming under the third generation solar cells. Okay. So we will. So basically, these third generation solar cells, they are at the research and pre-commercial stage. So they are currently the focus of the researchers. And why so? Because of their more efficiency, then more abundant material is available, then non-toxic materials are used here, and durability is higher. Okay. So type of third generation. The first one is the organic photovoltaic cells. So organic photovoltaic cell, it converts the solar energy to electrical energy. So it is basically it is a bilayer where this is the arrangement of a organic photovoltaic solar cell. So basically cathode is there, then buffer layer, then acceptor layer, donor layer, and anode. Okay. So what happens is sunlight is absorbed in the photoactive layers composed of. So here sunlight gets absorbed and composed of donor and acceptor semiconducting organic materials to generate photocurrents. What happens is the sunlight gets absorbed here, and donor material, it donates an electron. This donor material, it donates an electron to the acceptor layer. Acceptor layer accepts the electron and helps in the transportation of electron. And as the donor layer donates an electron, hole is created here and hole moves in this direction. Okay. So here electron moves and here hole moves. So hole moves here and creates a positive charge, and electron moves here and creates a negative charge, and here in this direction current flows. Okay. So mechanism in organic photovoltaic solar cell. Basically, the first one is light absorption. Sunlight gets absorbed. Then, due to the concentration gradient, the excitons diffuse to the donor acceptor interface and separate into the sunlight gets absorbed, and the as I have told here, sunlight gets absorbed, and here this donor layer donates the electron. Donor layer donates the electron and acceptor layer accepts the electron. So donor layer on donating the electron creates free holes, and and after the creation of the hole and the electron, they moves in the opposite direction, which comes under the charge separation. And photovoltaic is generated when the holes and electrons move to the corresponding electrodes by following either the donor or acceptor phase. So after that, charge extraction takes place, charge moves to their respective electrodes, and current flows into the external circuit. Okay. So why organic solar cell? That is because it is easier to process, then mechanical flexibility is there, economical viability is there, safer for environment since there are no toxic materials are used, toxic metals are used, less expensive than inorganic materials. Okay. Now coming on to the dye sensitized solar cell. Okay, dye sensitized solar cells are basically, they consist of a dye. So manufacturing of a dye sensitized solar cell is simple, mostly low cost and incorporate environment friendly materials. They have good efficiency of 10 to 14%. Even even when the sunlight is very feeble or it is very faded, then also it has a good efficiency of 10 to 14%. However, a major drawback, it is the temperature sensitivity of the liquid electrolyte. So liquid electrolyte is used here. So the problem with the DSSCs is that the temperature sensitivity of the liquid electrolyte is a problem. So a lot of research is going on to improve the electrolyte performance and cell stability. Okay. So here the mechanism of DSSCs is the dye molecule. It is initially in the ground state. Here a dye is used, that is the TiO2, which is denoted as S. The semiconductor material of the anode is at its energy level, that is non-conductive, and when the sunlight falls onto these dye materials, dye molecules get excited from its ground state to the higher energy state, and it forms a radical by S star by absorbing sunlight. Then excited dye molecule has now high energy content and overcomes the band gap of the semiconductor, and the excited dye molecule is oxidized. So the electron is extracted from it. An electron is injected, an electron is extracted from it, and it forms S positive, and the electron is injected in the conduction band of the semiconductor. An electron can now freely can move freely as the semiconductor is conductive at its energy level. Okay, so the electron is injected, extracted out from it, forming it as forming it into S positive. Electrons are then transported to the current collector of the anode via diffusion, and an electric load can be powered if connected. Okay, so the electron flows from here towards this direction, and if we connect a load here, then it can be lighted up. Okay, so the oxidized dye molecule, this S positive, it is again regenerated by electron donation from the electrolyte. So electrolyte is used here, as I told, which consists of iodide ion, which regenerates this S positive dye molecule for further next cycle. Okay, so for the generation of continuous electricity, this oxidation and reduction procedure takes place continuously. Okay, oxidation of dye molecule using the energy from the sun, and then reduction by electrolyte takes place continuously for the continuous generation of electricity. Now coming on to quantum dot solar cells. Quantum dots are used as the light absorbing photovoltaic materials in solar cells. So basically quantum dots, they are the nanoparticles. Basically quantum dots, they are simply particles like 0D particles, mainly in the spherical shape. So what happens here, quantum dots are used, which have the advantage of tuning their properties by changing the size. So if we change the size of the quantum dots, as I told, changing the size can adversely change the property. So if we change the size of the quantum dots, we can change the efficiency of the solar cell as well. So quantum dot solar cells use solution process nanocrystals and are useful for their integration into the various solar cells. So, but the major challenge include inadequate understanding of the surface chemistry of quantum dots. The only disadvantage is quantum dots is that there is not proper understanding of the surface chemistry of quantum dots. Okay. Now coming on to the nanocrystalline based solar cells. So there are various nanocrystals such as fullerene, CNTs, which are used for the which can be used as N-type or P-type semiconductors in organic photovoltaic cells to generate electricity from the solar cell. Okay, so there are various nanocrystals, nanocrystals. That is, for example, fullerene have most Lee sparked interest in N-type semiconductor, which is used in organic field transistors and organic photovoltaic cells. Then carbon nanotubes are also used in the preparation of counter electrodes in dye-sensitized solar cells and transparent electrodes in OPVs. Then graphene-based ultra-thin films can also be used as electrode for OPVs. Okay, then there are unique geometry of nanowire arrays can also allow for low optical reflection. Basically, here they are trying to tell us there are various nanomaterials which can be directly used as N-type or P-type semiconductors or as electrode in the solar cells to generate electricity. Okay. This is a comparison of first, second, and third generation solar cells. So basically, here they are trying to tell is the third generation, it is the best type of solar cell because they produce the best type of solar cells since the technology, it is a thin film based technology, and all the materials which are used are non-toxic. They are available in that abundant in the earth crust. Then low cost is there, transparency there, and but the only problem is there, we need to do the as I told, currently research on third generation solar cells is still going on. So the only problem with that is we need to do the optimization of the lifetime efficiency and cost. Okay. So use of nanotechnology for harvesting solar energy. So why nanotechnology is required? So as I told, nanotechnology it is a very powerful tool since it helps in the tailoring the interaction of light with material. It can also it can also modify or enhance the interaction of sunlight with the material and enable the processing of low cost semiconductors, then making more efficient photocatalysts, developing new materials and membranes for the separation needed in many energy applications, then converting chemical fuel into electrical energy. So basically, nanotechnology it is a versatile technique which is almost used right now in almost all the all the fields. Then how selection of nanomaterial is done for solar energy harvesting? What are the basic criteria? Okay, so these are some of the criterias. Basically, uh, some of the criterias are there should be proper band gap of at least one in between 1 to 1.8 electron volt to harvest maximum sunlight. Then good charge transport property should be there. Then excellent stability should be there. Then cheap cost should be there. Okay, and these are various applications where these solar cells can be used. Just a second. Okay, now coming on to one of the most uh, currently researched type of solar cells, that is the perovskite solar cell. It is a type of solar cell which includes a perovskite structured compound. So basically, perovskite structured compound, what it is basically a compound which is named after the scientist who discovered it. So it is in the form of basically AbX3 crystal. Okay. So basically A and B, they are two cations of very different sizes, and X is an anion that bond X is an anion which is in between A and B, and it bonds to both the A and B. Okay, so perovskite solar cell it is derived from the AbX3 type of crystal structure of the absorber material, and the most commonly used materials are hybrid organic inorganic metal halide based materials. So the most common perovskite absorber is methyl ammonium lead halide. Okay, so this X, it is halide. It can change. It can change to whatever halide you want to use. Okay. So the properties of perovskite material, there are it has high absorption coefficient, high carrier mobility, then long charge diffusion length, then band gap tuning, high crystalline structure, and low exciting binding energy. Okay. So these are some of the what makes perovskite stand among all other solar cells. So basically, they have a very low cost, then low finished cost, finished material cost, then low fabrication cost is there. Energy payback is also very payback period is also low. Then levelized cost of energy is also low, and moreover, its efficiency is very high. Okay. So classification of perovskite structure, it is basically two types: inorganic perovskite structure, inorganic oxide perovskites, then halide perovskites. Okay, so there are different kind of perovskite structures are present basically, which are classified as here. Now coming on to the perovskite solar cell device structure. So basically the device structure related material and interfacial modification are key factors in performance of solar cell. So two typical structures can be constructed. Basically, the one is mesoscopic structure, another is planar structure, and it consists of two layers, basically electron transport layer and hole transport layer. So electron transport layer is used to collect and transport the electron, and hole transport layer is used to collect and transport the holes. So these are different configurations of perovskite based solar cell, uh, which use different orientation of different layers, as we can see here. hole transport layer is there. Then here hole transport and electron transport layer is in this arrangement and perovskite is sandwiched between. Whereas in this one, the arrangement of electron transport layer and hole transport layer is reversed. And here we can see that perovskite is coated on, above, like above the nanoparticles. So what is electron transport layer? It is basically the basic function of electron transport layer is to form an electron selective contact with perovskite light absorbing layer, and it improves the extraction efficiency of photo generated electrons and prevents the whole migration to the counter electron. So basically, electrons should go to a definite. Electrons should go to a definite electrode, and hole should go to another electrode. So to prevent the cross motion of the electron of the hole, this electron transport layer is very important and reduce the recombination. And we should also use the electron transport layer so that it should reduce the recombination of electrons and hole. Okay. So properties required in selection of material for electron transport layer. The properties are it should have high electron carrier mobility, transparent and visible light, and band structure should match with the perovskite material, and preparation of material at feasible condition and low temperature. Okay. It's now some of the nanomaterials which are used as electron transport layers in inorganic materials, that is the titanium dioxide and zinc oxide, and organic material basically PCBM, which is phenyl C61 butyric acid methyl ester, and PFN. Okay. Now, hole transport layer is used to collect and transport holes from the perovskite light absorbing layer to promote the separation of electron hole pair. So basically, it is responsible for the transportation of the hole. Properties required are the high hole mobility, wide band gap. Their band gap should be according to similar to the perovskite material, but here wide band gap is required. Simple solvent treatment processes and high film ability. And materials that are used are basically inorganic material, that is copper iodide, nickel oxide, then CSSNI3, CuGaO2, and organic materials are as such. Okay. Now, classification of synthesis procedure. So, how to synthesize perovskite solar cell? This is the classification given here. And the first one is the solution process. Solution process, what happens is simply a simple low cost technique like spin coating is done. So, one step and two steps spin coating materials are used. So, in one step, what we do is coat both the we coat both the both the material, that is the lead iodide and CH3NH3I, uh, mixed in a solution, mixed in a solvent, that is DMF, and we coat it over the substrate and we drop cast it over the substrate and do the spin coating and heat it for annealing. So this is a one step procedure. And in the second step in two step coating, what we do simply uh, over the substrate, we drop the mixture of PbI2 and DMF firstly, and it is spin coated. Then after that, another second over that mixture of CH3, N3I, and DMF is coated, drop casted, and that is spin coated, and after that it is heated for annealing. So basically, this is a basically a example of we have taken a specific example. So basically, if suppose in this case we have drop casted this whole system once and spin coated it and annealed it, whereas in this case we have firstly drop casted this mixture, then drop casted this mixture, and annealed it after that. Okay, so that is a two-step spin coating. That is the explanation of the same. Vapor deposition, another technique is the vapor deposition. So we can take vapor deposition. What will happen? We will take the substrate, and co-evaporation is simply we will take both the precursors, solid of both the precursors, we will heat them, and when the vapors of these precursors will come out, the substrate will come in contact with the vapors, and along with the vapors, these precursors will get deposited over the substrate. Okay, that is co-evaporation. Then sequential evaporation is basically firstly we will heat one precursor and it will get deposited over the substrate, and then we will heat the second precursor and it will get deposited over the substrate. That is basically the sequential evaporation. And then one other technique is the vapor assisted solution process, which is in which one material we will drop cast over it and do the spin coating, and after that other material, and then it is annealed in the presence of vapors of second material. So it is basically the mixture of the both the before techniques, that is the vaporization and solution wo spin coating technique are both assisted together. Okay, both used together. So these are the advantages and disadvantages. So advantages involve it is of perovskite, that is high efficiency, which is an efficiency of 23.3. Then fissile low temperature solution based fabrication techniques, then high absorption coefficient, high diffusion length, and high charge carrier mobility, very high value of open circuit voltage. Okay. And disadvantages involve mass production of metal oxide coated solar cell is expensive and difficult. Degradation of perovskite. Perovskite degradation is also a problem. So we need to fabricate all these perovskites, or we need to prepare the perovskite solar cell in very closed and inert atmosphere. So if we do not prepare these perovskite solar cells in inert atmosphere, they will degrade very easily and efficiency will be affected. Okay. Another is the toxicity of lead-based perovskite solar cells. Okay, these are the applications where these lead perovskite-based solar cells are used, basically in FETs and photodetectors and single photon emitters. Now coming on to the another kind of technique, which is the I have told you is the solar thermal power. So what happened till now? What we did, all the solar energy production was directly from the heat and light. Directly we are taking the energy from the sun and converting it into electricity. Whereas in the case of solar thermal power, as I told earlier also, we take sorry, we take light energy from sun, and convert it into heat energy first, and then this heat is used for the generation of electricity. Okay, so solar thermal energy, it is relatively new technique. So basically here we can see this sun is heating the water in the coils, and then this water and then this water is used for the generation of steam, and this steam is will be used for the turning of these turbines, and these turbines will further help in the generation of electricity. Okay, so this is mainly the concept of solar thermal power. So nanoparticles can improve thermal. So where nanomaterials are used here in this technique, that we will be discussing further. So let me give a gist. So nanoparticles are basically used in the liquid. So it is not like every time we will use water only. We can use different kind of heat transfer fluids depending on different properties, and these nanoparticles will be used in this heat transfer fluid to improve its thermal properties, so that we can extract the maximum amount of heat energy extract from the sun and use it in the generation of electricity. Okay, so the difference between solar thermal and photovoltaic technologies is simple, that it has a very high efficiency. Efficiency here is 20 to 45%, which in the case of photovoltaic technology could only reach up to 24 degrees C. then its storage cost is less, even though it takes it forms electricity in two steps. Firstly, to heat, then to electricity. Then also it is less costlier compared to the photovoltaic technology. Used well-known thermal conversion system, and whereas here it directs photons to electricity, converts sunlight into heat and then to electricity, and converts sunlight into electricity directly. Okay. So the working principle, as I told, firstly the sunlight is concentrated on a large concentrator. Then this sunlight incident on the receiver is converted into heat by an absorber. This concentrator will concentrate the sunlight to a small receiver, and this receiver at this receiver there is an absorber. Basically, that absorber will absorb the heat, and heat is carried away. That heat is carried away by a heat transfer fluid. This absorber consists of a heat transfer fluid which carries away all the heat uh, from there, and heat can be stored in a thermal energy system or it can be used for the generation of electricity. Okay. Classification, it is basically various different type of classification. Low temperature classification is there. Medium low temperature, that is less than 100 degrees C, medium temperature less than 400 degrees C, and high temperature greater than 400 degrees C. So we will be talking further. Low temperature, that is less than 100 degrees C, that is flat plate collector. Here flat plate collector that you might have seen normally on the floor of the buildings, this type of collectors are there. So these flat plate collector is basically a black surface which is convenient, that is placed at a convenient path of sun. So sun heats the dark flat surface, and and inside it there are coils that so this heat energy is converted to water, air, or whatever fluid is flowing inside, and they are used in domestic household for water heating or space heating. Okay. So they operate at a temperature range of 30 to 80 degrees C, because if we increase the temperature range after that, then water will start boiling. Okay. Then solar chimney is another type of low temperature water solar thermal power plant power. So what happens here? The solar radiation, it heats the air. This is a kind of collector, and this is a chimney. So solar sunlight falls here, and it heats the air. So here uh, uh, pressure is low, and it heats the air, and air pressure is low, here air pressure is high. So uh, uh, hot air flows through the chimney to the upper direction. The temperature differences causes a due to the temperature difference of the temperature of the air, a pressure drop is created over the height of the chimney, resulting in a upwind direction. This flow of upwind rotate, and inside the chimney there is a turbine which generates electricity via conventional generators. Okay. Then solar pond. This type of solar pond is used for generation of electricity. Then solar pond, it has three different zones. So basically this is the surface zone, this is the insulation zone, and this is the storage zone. So basically it is a brine solution. Brine solution is the solution of water with salt. So here salt concentration is the highest. So basically, the storage zone, this sunlight falls over the surface, and due to and from the convection heat, the whole water gets heated up. Storage zone collects and store. This zone collects and stores solar energy in the form of heat, and the trapped solar energy is then withdrawn from the pond. And here this portion, due to the presence of salt helps in the storage of more amount of heat. So here the concentration of salt is very high in this storage zone. So here due to which water is extremely high, and by using a coil we can heat the water by passing a coil, and through which cold water flows in, and using the heat stored here the water gets heated up and hot water comes out. Okay. Medium temperature collectors, basically less than 400 degrees C. The first one is parabolic straw collector. So this is a basically a shiny surface which is cylindrically curved sorry. Hello. Am I audible?
Yes, ma'am.
Okay. So what happens in the parabolic straw collector? Parabolic straw collector, it is a linear focus collector. So what happens is the sunlight. Oh, sorry. So sunlight falls onto this parabolic surface, which is a shiny surface, and sunlight gets focused onto this pipe. Okay, this is basically the receiver, and water flows through this pipe. So what happens? This water flowing through this pipe gets heated up. Okay, so this is the receiver, and water flowing through this pipe gets heated up, and steam is generated using this heat, and further is used for the generation of electricity through turbine and generator. Okay. Now another is the Fresnel collector. So in the parabolic straw collector, only a single it is formed by simply bending a sheet of reflective or highly polished material into a parabolic shape. Whereas in the Fresnel collector, what happens is we have uh, different numerous amount of Fresnel collectors use long thin sheets of mirrors to focus sunlight onto a fixed absorber. So these long fixed segments of mirror are kept which focus the light onto a single absorber. Okay, oh sorry, single receiver. Okay, receiver basically absorber. So these mirrors, they some have mean all they have different focus, different direction of their focus. Okay, some are arranged in this direction, some are arranged in this direction, some are arranged in this direction. Why so? Because sun changes its position throughout the day. So at whatever position sun is there, okay, one or other Fresnel collector will collect the sunlight and focus it to the receiver. Okay. So that is the reason. That is the main requirement here, that different direction angle of fixing the Fresnel collectors is used so that at any point of time of the day, some amount of sunlight is focused to the receiver and it is generating energy continuously. Okay, so these mirrors are capable of concentrating sun's energy to approximately 30 times its normal intensity. So this concentrated energy is transferred through the absorber into some heat transfer. So this here receiver is there, then this receiver transfers this energy into a absorber, and uh, absorber into a some heat transfer fluid, and the fluid then goes through a boiler or heat exchanger to provide to power a steam generator. Okay. Now coming on to the high temperature collectors, basically greater than 400 degrees C. So they are basically central tower collectors. So this is a central tower, and numerous collectors, numerous receivers, basically tracking mirrors are arranged around the receiver, which are basically called the heliostats, which are positioned in the field around the central receiver installed on a tower. Okay, so these systems, they are capable of reaching of much higher level of concentration than linear systems. Okay, so typically 80 to 95% of the total reflected energy is absorbed into the working fluid, which is pumped up into the receiver. So this this receiver takes the receives the solar energy, and the working fluid is and reflected energy is absorbed, and this energy is further absorbed into a working fluid which is pumped up into the receiver, and the working fluid is used as the heat source to produce steam and convert it into electricity. The generated thermal energy can be stored in a molten salt storage. Okay. We can also store this thermal energy directly without converting into electricity. We can also either we can generate electricity or we can store this thermal energy directly for further use. Okay. Now coming on to the another is the parabolic dish collector. This is basically a type of dish TVs you guys all have seen in your homes. This is a kind of dish TV. That dish TV also has a, I mean, antenna kind of thing, which is A similar arrangement is seen here. A parabolic dish collector looks like a large satellite dish. It has mirror-like reflectors and receivers at the focal point. Okay, so this is the receiver, and in some systems, a heat engine is linked to the receiver to generate electricity. Okay, so the parabolic dish collector can achieve above 10,000 degrees C at the receiver. Okay, so it is not a single mirror. There are various mirrors which are arranged in the form of satellite dish, and it focuses the solar energy and gives and it receives the solar energy and provides it to the receiver at above receiver, and it may reach up to a temperature of 1000 degrees C, and the working fluid here normally is used is the hydrogen or helium, and the receiver is heated up to 250 to 700 degrees C and then used by a Stirling engine to generate power. Okay, so why we use nanomaterial in this solar thermal energy? So basically, nanomaterials mean, if you now question me that what, why, where nanomaterials are used here. So nanomaterials are basically used in the heat transfer fluid. Okay, and what kind of nanomaterials? Various nanomaterials can be used. Okay, so suppose this is a receiver. So this in the receiver or absorber, this is a pipe in which heat transfer fluid flows. Okay, so in the absorber where nanomaterials are used in the heat transfer fluid also. Then absorber, what kind of nanomaterials? Absorber and anti-reflective layer coated tubes are used, majorly involved to improve the receiver efficiency. So this tube is coated with the anti-reflective layer. Okay, anti-reflective layer, why? So that all the sunlight that comes in is absorbed and none of it goes back out. Okay, so that is why anti-reflective layer is used. Absorber tubes absorbs heat from the reflector and transfer the heat to the heat transfer fluid. Absorber tubes are covered with anti-reflective layer coated tubes which are used to entrap the sunlight and let not reflect back in order to create more heat. So different nanomaterials are used to improve the performance of the absorber and anti-reflective layer coated tubes. So selection of nanoparticles for solar absorber collectors. So basically, it should have high absorptivity, low emissivity, strong addition, corrosion and wear resistant, and high thermal conductivity and high durability. So different kind of nanomaterials are used. That is nanopyramid, tungsten, then nickel, silicon, then copper oxide nanowires with cobalt oxide nanoparticles, then copper, nickel, cobalt tandem layers, and copper, nickel, manganese tandem layers. Okay. Now selection of nanoparticles for anti-reflective coatings. So what kind of nanoparticles should be used for anti-reflective coatings? It should have excellent optical qualities. High temperature tolerance should be there, since the heat transfer fluid inside the tube may reach up to 700 800 degrees C temperature also. Then therefore that nanoparticle should have high temperature tolerance. Then it should have resistance to moisture and UV degradation. Then low cost should be there. So these are the nanoparticles which can be used. That is the silicon oxide nanostructures, manganese fluoride nanoparticles, silicon dioxide or titanium dioxide composite. So different methods which are used in coating. Chemical method, basically simply spraying the nanoparticle over the tube, or simple chemical coating can be done, or electrodeposition by depositing the nanoparticle coating over the tube using electricity, basically by reducing the cation of the desired material from a solution and coating that material as a thin film onto the conductive substrate surface. Then vapor deposition, basically whatever coating you want to do over the tube, we need to take the solid of that material and heat it. When the vapors of that materials are generated, it gets deposited over the tube. Okay. Oxide method, basically metals used in early solar collectors such as copper and iron, they undergo natural oxidation which act as which have desirable absorptivity. So they have anti-reflective properties, natural oxidation. Then dip coating is simply dipping the tube inside the desired anti-reflective material. Okay. So these are the advantages of solar thermal power. So there will be no fuel cost as the power plant runs by sun energy. It does not cause pollution and global warming effects. It uses existing equipments like solar thermal mirrors or turbines and can store energy using molten salts instead of using batteries. Molten salts or molten or like heat transfer fluids, and uses less space than photovoltaics, and running cost of solar thermal plants are cheaper than uh, like coal or gas plants. Okay. And the disadvantage is the initial cost of the uh, solar thermal sorry, the disadvantages are the initial cost, means setup cost is very large, and use of lot of water, which is major problem in desert areas. Mean if you we need to use huge amount of heat transfer fluid and everything, and mainly we use water, so that is also a problem. Usage of massive arrays of mirrors impact the wildlife species. Mean obviously if we install thousands and lakhs of mirrors somewhere, it will be a problem for like wildlife species. Okay, so these plants can be installed only in places which have high amount of solar radiation. Solar thermal can't be installed in residential areas, as I have told. Then build time would be longer than any form of energy generation, than other form of energy generation. Okay, and these are the applications. Okay, so now let us come to the some of the questions. I have prepared. Mean these are some of the questions. I will be mean these are the assignment questions, and it would be great if you guys would answer. Okay. So the first question: what is the working principle of triboelectric nanogenerators? Anyone? So as we have, okay, let me answer. So as we have discussed, triboelectric nanogenerators, they are basically the electricity which is generated due to the when we I mean due to the contact of two different metals. If we rub two different material sheets together, then one sheet gets loses electron, other gets other gains electron, and potential difference occurs. So tribal due to that electricity is generated, or electricity is generated. So that is the cause of mean working principle of triboelectric nanogenerator. So here the option is coupling of contact electrification and electrostatic induction. Okay, so the answer is C. Coming on to which particle is bombarded on the heavy nucleus of nuclear fuel? Mean which particle is basically responsible for the generation of nuclear energy? So the answer is neutron, basically. Since nuclear energy is generated through nuclear fission, where two neutrons, sorry, a neutron gets splitted into two daughter nuclei, and other is nuclear fusion, where two neutrons get fused to give one parent nucleus. Okay, so basically, neutron is the right answer. Another is the soul gel is dash of solid particles. Anyone? So sol gel is basically colloidal suspension of solid particles in a liquid. Okay. Which of the following is the selection criteria for choosing nanoparticles for solar energy harvesting application? As I told you, the criteria is it is basically the band gap should be in this range, then excellent stability should also be there, and high charge transport property should be there. So the answer is all of the above. Okay. Coming on to the volt is the unit of EMF that was named after its inventor. Who is the inventor basically? I guess I missed this slide, so I must tell the answer. The inventor after which the volt, which is the unit of EMF, was named is Alessandro Volta. So to be classed as nanoscale, an object must have
1 to
anyone.
100. 1 to 100 nanometers. C.
What is the range of particles to be in nanoscale?
1 to 100 nanometer.
So basically, nanoscale should have dimensions. At least one dimension should be in the range 10 to 100 nanometer. At least one dimension. Okay. Which of the following nanomaterials is used commonly as a nanofiller in tank? So in the last slides I have showed barium titanium dioxide is one of the fillers which are widely used in tank. Sorry about this.
Carbon nanotube. Filler. TENG. Carbon nanotubes.
So the answer of this is in tanks, carbon nanotubes are widely used as fillers.
Carbon nanotubes.
The next question is the phenomena that hydrogen can be stored on the surface of solid is.
Adsorption.
Basically, anyone?
D. Answer. Sorry, adsorption. A.
Anyone?
A.
Okay. So the phenomena basically hydrogen can be stored either on the surface of the solids or inside the solid by two phenomena. On the surface of the solid basically by adsorption, and inside solid by absorption. So basically the answer here is adsorption. What are the two basic steps in the operation of a photovoltaic cell? The two basic steps in the operation of photovoltaic cell is basically light absorption and electron hole pair separation. Okay. Light will light will be absorbed, then electrons will move in one direction, leaving hole to move in the other direction, and electron hole pair separation will take place. Okay. Now the formula given by Park and Cho. Sorry, this is a question. Okay, leave this question. So, 11th question. Match the following. So basically here in the section A, here are different type of materials, and in section B is the description of them. Okay. So 0D material basically they have all the dimensions in nano range. Okay. So basically their no dimension is in micro range. Okay. So the 0D is no dimensions are in micro range. 1D, one dimension is in micro range. Okay. Then 2D, two dimensions are in micro range. And 4D, all dimensions are in micro range. Okay. So it is 1C. So C is sorry. B is the 1C, 2D, 3A, 4B. Okay. B is the answer. Coming on to the next question, which is the mechanism involved in solar thermal energy harvesting technology is. So the mechanism involved in, just now we have studied, sunlight first converts into heat and then electricity. Okay, so the B is the answer. Now coming on to photolysis of 6 water molecules result in. So 6 water molecules will give how many atoms of hydrogen? It is very simple. It is 12 hydrogen molecules. And 6 oxygen molecules. Okay, 12 atoms of hydrogen. Okay, so the answer is 6. That is 12 atoms of hydrogen. What does piezo and piezoelectricity mean? So piezo basically means to provide pressure. Okay, so it is, the answer is to press. Okay, so by applying pressure, electricity is generated. So these are all the assignment questions. Thank you all for your patience. Am I audible?
Yes, ma'am, you are ideal.
I hope today's lecture was clear. I have missed a portion. Actually, it was getting a bit longer. So I will see maybe if in the upcoming classes I can like concise my lectures a bit more, and then I will try to include this portion. Actually, I missed the portion of heat transfer fluids. The class was extending a lot. I will try to accommodate that in the upcoming lectures if possible. So, any question? Okay, just a second. What question? Okay. Should we follow the information that now should we use the latest available data? Okay. Actually, that the professor can only tell, but I will definitely solve your issue. Can you please provide your okay? Can you please provide me that is actually if it is in the if this acoustic energy, I guess it is not in the syllabus. So I will be trying to stick to the syllabus. So I think acoustic energy is not there. And you who's Arunmay Vaidya, you can please write down. Message me your mail ID. I will ask your query with the professor and let you know, because this will definitely only be decided by the professor. So please write down your mail ID in the message, and I will ask him about your query, and I will definitely mail you back. Okay, will that be fine? Hello, Mr. Okay, I will definitely ask your question. And okay, you guys were answering here, I did not see, sorry for that. I will definitely see it in the next class. Okay. Okay, any other queries? Okay, okay. Okay, fine. I will, you guys, just a minute. Let me note down all your mail IDs. Just give me a minute, okay? Just give me a minute. All those who need, or you guys can do one thing. You guys can add me on WhatsApp if that is possible. I mean, you can make a group and I can provide you the number here. So if you guys can add me and I will convey this, I mean, your queries in the WhatsApp group. Okay, will that be fine? I guess that would be much fine. Because this mail, I don't know how many. Okay, just a minute. Okay, I'm providing you my mail also. So if you guys have any issues, just mail me directly. That would be also convenient for me. All those who have provided your mail IDs, I will mail them back. And apart from that, if anyone else have any query, they can please. Okay, I am giving you the number, WhatsApp number, so you guys can add me on the WhatsApp group also if you guys want. Okay, and mail ID also, whichever is convenient for you guys. You can mail me or you can WhatsApp me. I will provide you the necessary information. Okay, just give me a minute. I'm writing down all your mails. Then you can leave if you want. I hope whatever I taught it was clear. I tried to be clear as much as possible, but still, if you guys have any issues or any questions in the future, you guys can. I don't think so. There is a WhatsApp group. Actually, I'm also a TA, so I don't have issue. I mean, I don't have an idea if professor has made a group. I will definitely ask him. So just a second, I'm writing down all your mails and then I will ask the professor. I'll and then let you know. Okay. You guys can make, if you guys want, you guys can make a WhatsApp group and you can ask me the queries you want to ask. Okay. I will write it down, write your question. Okay. Any other questions? I have noted down your um, mail IDs and I have given you my mail ID also. So if I miss anyone and you guys have any question, you can mail me and ask. Okay. Okay then. Any other problems? And if not, we can stop today's class. Okay, fine. You just create a WhatsApp group and add me. Then I will send the link for the class. Okay. So next class, let us meet the next class. Okay. And if there are any changes in the schedule also, I will let you know. Let you know. Okay. Okay, chalo. Thank you, everyone. Okay, I'm leaving.